Hi friends, so you can see I have a HDMI monitor now. It is actually I was using it for my video capturing, and then now I'm using it for my robotics project. So it's an HDMI 4K monitor, and I connected the HDMI port with my Raspberry Pi 5 8GB RAM version, and then I connected a camera with the Raspberry Pi, and also a USB keyboard and mouse, which is here, and by this I am operating my Raspberry Pi through the monitor. So it's a complete system, standalone. And then what I'm trying to do is I want to capture the image from this camera and try to do some face detection. So this is the code, face detect.py. We'll go over the code, but before, let's see a demo. I just started the camera, and you see the camera popped up, and then let me show my face, and then I'm blocking my face. Let me focus on the screen, zoom it, and then I will show my face to the camera, and you see it's drawing a square block around my face and 2 square on around my eyes, detecting my both. Maybe I can remove the speck. That's another thing. With speck there might be another training logic. So without speck, I think it's somehow detecting, but you got the idea, right? So let me come back. Okay, so how the code is working, let's close it. Hope escape should work. Yeah, that's the code written. So it's written like CP wait key 30 or this one, and then K equal to 27, then break, and wait for escape key to stop. That's what it's mentioned. So okay, let's go over the code. So let me clean the monitor or the console first, and then freshly show the code. So this is all code. Let me settle my mobile and then scroll to the top. So it's downloaded from internet. It's, as you can see, it's well documented. It is using OpenCV Python library, and it's a Python code, obviously. .py is there, and this OpenCV Python library, what it is doing actually is it's using an algorithm called Haarcascare. So it AI, or it is trying to find out from your face or any object some edges and lines. So based on that, it will where the edges are, and what is the location, what is the length, and all these few parameters. Based on that, it can detect that what kind of thing it is. Is it a face, is it an eye, is it a dog, cat, or any object you train it for, and then, so that's what it is. And then this feature, how a face looks like, is already captured by somebody in Python community, and that is available in internet, and it is directly accessing that path from internet. Similarly, for eye, there is a pattern, and it is also capturing accessing that. And finally, through this video camera, which is the index number 0, because I have only one video camera attached, so index number 0, and it's capturing the video. And out of the this is a video adapter, and then we are running an infinite while loop to keep capturing image out of the video, which means actually the video is a series of image, right? So in a series of image, if you play through, and then it's actually video. So it's capturing the image one by one, whatever is coming from the camera, and then from on each video it is applying this logic. So what is this? This is reducing the image size. So every pixel is actually a RGB colorful image, but we don't need a colorful image for this algorithm. It's just a simple black and white is enough. So for that, what it is doing, it is just converting the colorful image into a black and white or gray color image, gray shade image, and then it is trying to detect face out of it. And then how many faces was detected, that will come as an array into this, and then we are iterating over the array and drawing a bounding rectangle box around it. And finally it is passing it through the eye cascade, means finding out all the eyes, and then iterating over the eye. So I was alone there, so there was this for loop will iterate only one time, because only one face is detected for my case, and 2 eyes. detected. So this for loop will run 2 times, and finally it will embed all the squares, rectangle, everything into that image that it was processing, and finally it will show that image. So you will be seeing that rectangle around my face and eye, because it hijacked that image, it detected my face, eye, and then it drawn a rectangle into that image, and then finally displaying it into that screen that you are seeing. And while it was doing infinitely that, in parallelly it was looking for when the user is pressing that escape button, and then once it press escape button, it's breaking from that while loop. So break is the only way you can break or return. So break is one of the way to come out of the infinite while loop. So that's how it is doing, and finally it's releasing the video capture, so that yeah, it's a proper way of closing the video adapter handle and then destroying all the window, that pop-up window, and it's clear, everything is clean and clear, no leak, and it's coming out. That's how it works. So this is just a sample code how to do face detection in the Raspberry Pi, but this is not the end, this is the start, because after this, once you found that where exactly your face is, this XY value, you can figure out which direction. Suppose it could be a robotics project where instead of line following robot or light following robot, it could be a human following robot, where it will detect human face or human eye, and then it will try to go that direction. So how to find out the direction, which side the wheel to move? I mean the whole Raspberry Pi with this display, or maybe the Raspberry Pi alone with the camera, can sit on a robotics car, and a robot car, 4-wheeler or 2-wheeler and 1 caster wheel car, and then based on this human face detection, it will find out which direction the human is it in the extreme left or extreme right or in the center. Based on that, it will turn left, right, or center, and it will keep moving following the human. So that could be a nice project, a simplest project using OpenCV and Raspberry Pi. We can try off. If anybody is interested, let me know. Thank you.